Here we are at example 4 from our 2.8 set of notes. We're asked to write an inequality for each of these graphs. And for this first one, we notice that we have a line here that's comprised of these 2 points. So we have a point right here, looks to be at 0, 4. And then we have this other point right here that happens to be 3, 0. And with these 2 points, we can eventually come up with the equation of this line. So with the slope, we know that it's y2 minus y1 over x2 minus x1. And again, it doesn't really matter which point we let x1, y1 be. We'll just say that this one's going to be x2, y2, and this one will let be x1, y1. So x1, y1, and x2, y2. So then our slope m is going to be equal to, looks like 4 minus 0 over 0 minus 3. Simplifying this, it looks like it comes out to be negative 4/3. So our slope is negative 4/3. And we can even actually just count that. So down 4 over 3. That would be your rise over your run. So now that we have our slope, we can go ahead and use our point slope using one of these points. Let's go with this one, 3, 0. So creating our equation of the line using point slope, we have y minus y1 is equal to m times x minus x1. And pretty much just throwing in our x1 and y1, we then end up with y minus 0 is equal to our slope, negative 4/3, times x minus our x1 is 3. So then this will just come out to be y on the left side is equal to negative 4/3 x. When we distribute that in, looks like we're going to end up with a positive 4. So here is our equation of the line, but keep in mind that would just be if we had a solid graphed line like this. But then we also have a shaded region that we're talking about. We see that we are shading above this line, and so we are essentially throwing in values that would make it true anywhere that is in this shaded region. So for example, we see this point 1, 2, 3, 4, 5 that's in the shaded region, and as a result it must satisfy then this equation, which will turn into soon enough an inequality. So if we throw 5, 0 in here, we would end up then with 0 is equal to negative 4/3 times 5 plus 4. Well, this would come out to be negative 20 over 3 plus 4, which simplifies out to be, this would be 12 over 3. And so really you'd end up with negative 8 over 3. Now the entire reason why we actually went ahead and plugged these in is, see how we have 0 on the left side and is equal to this negative 8 over 3 when we plugged in that x value? Well, in order for this statement to actually be true, our inequality would have to face this way. So then from our original equation, our inequality would have to face that way. You could even try a different test number for this. So for example, we could try the test number 0, 8. When we throw in 0, 8, we would end up with, we're going to again test 0, 8. We would end up with 8 is larger than or equal to negative 4/3 times 0 plus 4. Well, anything times 0 is just 0, so essentially this will just cancel out. And as a result, 8 is larger than or equal to 4. Well, that's a true statement. So again, it really just confirms that this inequality is facing to the left. And as a result, this would then become our inequality for this line. Now looking at the second graph, we see that this is the line y is equal to 2. Likewise, this line right here is y is equal to -3. Again, just talking about the lines, not talking about yet the shaded region. So now if we want to go ahead and confirm what is this shaded region, we have to go ahead and test some values. So for example, if we were to choose, let's just go with the origin, that's 0, 0. And as a result, just looking at this line, is 0 equal to 2? No, it's not equal to 2, but that can help us in determining what is this inequality. Well, in order for this to be true, it looks like 0 would have to be less than or equal to 2. And as a result, we can then change this line into y is less than or equal to 2. Similarly, looking at y is equal to -3, we can also go ahead and use the origin. Well, is 0 equal to -3? No, it's not. But again, it's just helping us set up our inequality. In order to make this actually true, we'd have to change our inequality such then that 0 is larger than or equal to -3. And as a result, from our original equation, y would then have to be larger than or equal to -3. We could even try some test numbers and just kind of confirm this. So for example, we could try 3, we'll go with +1. So the number, or I'm sorry, the point 3, 1. Well, again, here are our inequalities that we came up with. When we go ahead and throw in our point, well, essentially we're really only just using the y value. So is 1 less than or equal to 2? Coming from here. It most certainly is. Is 1 larger than or equal to -3? Coming from this part of our equation. It most certainly is. And as a result, it satisfies these two inequalities. Now you could test several different test points and see that both of these inequalities still hold true. But again, you're essentially looking for test points and seeing where is it true, just like we saw in the previous set of notes. Again though, that is example 4 from our 2.8 set of notes.